Well, we get to spend about 2 hours together talking about Kubernetes. Does that excite you? It should excite you. I've had a lot of fun with Kubernetes over the last few years. I'm going to tell you a little story, but I primarily want to focus on showing you Kubernetes capabilities from the basics to the more advanced. We'll see how far we get. We have about 2 hours together, and we're going to go pretty fast through this material. Now, there's one thing I want you to keep in mind. If it seems confusing, or if I feel like I'm going too fast, all this is documented. So in other words, we tried to write everything down so you guys have access to this information. So the first thing to remember, I'm going to use this slide deck here, okay? And let me pull this one up. But you'll notice there's a couple links right here. One is this GitHub repo. You want to make sure to have access to that GitHub repo because that's where the documentation is, that's where the examples are. That's an important GitHub repo for you guys to have access to. Let me see, I can pull it up higher on the screen there. And then there's another one at the bottom there. bit.ly 9 steps awesome is the slide deck. So the slide deck is open source, the source code is open source, the documentation is open source. At Red Hat, we get to do everything open source. So we try to make sure everything is available to you. So make sure you have those 2 links, and that is this intro class. Normally this intro class I run on O'Reilly for about 4 hours. We're going to do a bunch of it in 2 hours today and show you some of the highlights. Now, one thing I want you guys to think about when it comes to learning Kubernetes. The Kubernetes skill set at this point is much like having a Linux skill set. And I appreciate that a lot of people are still on Windows and doing, let's say, Visual Basic.NET, but not at this conference, right? This is a place where the Java people hang out, maybe some Node.js people. And if you do some .NET, you're doing .NET Core with C#. But we build Linux containers at this point. We run little Linux containers on side of an as part of our application, and we deploy that in great volume at this point. As a matter of fact, I'm going to show you this little demonstration, but we're not going to spend time on it today, just because it's kind of a fun one. We're going to actually talk more about this one tomorrow. But here's a good example. Okay, I'm just going to basically pump a bunch of messages into a Kafka queue. And now Knative and Kubernetes are going to dynamically auto-scale out for me. And so all I'm doing is just pumping messages in. So if you're kind of paying attention to this, you'll see that it's going to go from 1 container to 10 containers to 40 containers as it tries to get up there to 50. I know that's actually light gray there, kind of hard to see right there. And it's trying to basically dynamically auto-scale all those little application servers, all those little computers is being dynamically auto-scaled right now. So this is the power of Kubernetes. If you have to burst scale in real time to a bunch of load, you can. But this is using Knative, which is an advanced technology that sits on top of Kubernetes. And this is my session tomorrow. I'll be talking about this in tomorrow's serverless session. We can kind of see what's happening here, and we'll walk through this in more detail. But this is an example of Kubernetes in action. This is why Kubernetes is so amazing, because you can basically build a container and then say run it. And so we'll talk about what that means. So we're not going to wait on that to finish. We'll come back to that. All right, let's get into this. I'm trying not to bore you to death with slides, but remember the GitHub, bit.ly, and you're good to go. This is me. A couple more links there that you want to make sure you have access to. And if you have access to the slide deck, you have access to all the links in the slide deck. So just keep that one in mind. So those are the Kubernetes tutorial, which is what we're doing now. Then there's Istio, which I've actually done at Java Day Ukraine, back when it was Java Day Ukraine. So that one's a good one. And the Knative tutorial, which is all the serverless technology. So just remember all of those links, and you'll have access to these things. I run these 3 classes. Like I said, these are typically 3 to 4 hours, 3 hours, 3 hours. So about 9, 10 hours of training with the O'Reilly platform. And that's just something that O'Reilly offers if you're a O'Reilly subscriber. And then if we do this hands-on, you can actually run through the installation document yourself, get a Minikube or Minishift set up on your local workstation. I'm actually running Minikube, as well as Amazon, Azure, and Google right now. So I have 4 clouds running at this moment in time. Now, this was part of my Bruce Lee thing. I did a Bruce Lee thing about 1.5 years, 2 years ago, so I'm still kind of in that mode. Now, you guys have seen this from me before. I've shown this. How many people have been in one of my presentations here in Kyiv before? Oh, wow, a bunch of new people. I've been to Kyiv several times and spoken to hundreds and hundreds of you, and there's only a couple of you right now. Well, then you've not seen this. This is fun. And I actually like talking about the journey we're all on. If you think about the journey you're on as a software developer, you're trying to evolve, you're trying to grow, you're trying to transform into becoming a vastly better software architect and software developer. And one of the first key principles is adopting DevOps as a culture and DevOps as a philosophy, DevOps as a set of tools and technologies, as well as, making sure everybody plays nice together. Also, this concept of self-service, on-demand, elastic infrastructure is super important. Do you have to wait 3 weeks to get a virtual machine? Do you have to file a ticket where a vice president has to sign off to give you that access to that computing resource? Or do you have instant access to the computers that you need to do the software job that you want to do? When someone comes to you and says, hey, I have an idea for a new API, the marketing department says, I have a new concept that I want to use with a business partner. I just need a programmer, an architect who can build that for me. And you, because you're here today, I know you can do it. Very few people go to continuing education in software development. Only 1% of professional software developers in the world come to their local conference like you guys have done today. So you're the ones who are capable. You're the ones who have the skill. As a matter of fact, you have a superpower that almost nobody on this planet has. You can put fingers on keyboard and make magic happen. Think about that for 1 second. The whole world needs digital assets, APIs, apps, technology. And you're some of the few people on the planet. Of the 7 billion, there's what? 1,000 here today? Maybe more? 2,000 here today? So getting access to resources when you need them is critical. So we're going to see some of that when we talk about Kubernetes. Also automation. Don't feed CDs into CD trays. Automate everything as much as possible. How about a deployment pipeline? In our more advanced technologies, or more advanced classes, we show you the Tecton pipelines as an example. There's also Jenkins pipelines, Jenkins X, Jenkins 2, or Jenkins file. We can see blue-green deployments, canary deployments, things of that nature. So this is where you're doing incredibly fast deployment cycles, you're building applications and deploying ever faster, then you too can be like a microservices unicorn. But this is where Kubernetes, and at Red Hat we call this thing OpenShift, this is where it fits. Okay, right here in the middle. It helps you deal with this elastic self-service on-demand infrastructure. It helps you deal with a deployment pipeline. It helps you deal with full automation and blue-green deployments, canary deployments, things of that nature. Then you can be like this fellow here. Okay? So that's the journey we're on today. We're trying to learn some of this technology related to Kubernetes. Now here's the new old school way of thinking. You build a monolithic application, you deploy that monolithic application every 6 months. You might work for a company like this today, on a project like this today. You're so good at it, you deploy every 3 months like clockwork. Your vice president's incredibly proud of it. That individual is basically high-fiving everybody every time they get a chance to do a deployment every 3 months. The new world, though, says we deploy every day. We deploy every hour. We deploy every minute. As a matter of fact, Amazon is to a deployment per second now across their infrastructure. Think about that. So that level of speed means time to market. You can get time to market faster and therefore add value faster, because the code that you create as a software developer adds no value to the world until it runs in production. I don't care how pretty your code is, if you got all your curly braces lined up correctly, nice comments, great algorithms, adds no value at all until it runs in production. So the faster you get there, it's the faster value is realized for the organization in which you build that software. Whether it be a nonprofit, the local government, a big insurance or big bank, doesn't matter, okay? So this is the 9 steps class that I teach. We kind of run through all these things in that class. We're going to be able to touch on some of these things today, not necessarily spend a whole lot of time on some of this in detail, because we only have about another hour and a half. Now here is the real magic that started with the concept of the Docker file. How many people here have been hands-on with Docker at this point? D-O-C-K-E-R. Okay, that's pretty common, fantastic. So most people have done D-O-C-K-E-R before. Well, the reason Docker became so exciting to us is because we had this problem prior to Docker. We actually had an application that we created. If it was in Java, we produced a war file or an ear file or maybe a fat jar file. But then we had to communicate to the downstream developers the quality assurance team, the security review team, the production team, the operations team, what was required for that application. We had to tell them what data sources we needed. We had to tell them, what JMS queues we needed, what user IDs and passwords we expected. We had to communicate about what the JDBC driver was going to be and what jar file we're going to use for it. All that communication typically was documented in an email, or maybe even a wiki page when we got super sophisticated. So we would send that email or that wiki page over to a QA team and would say, hey, on my Windows machine, I built it this way. I used MySQL. I used Windows. I used Java 1.8. But in production, we have Java 1.7. We have WebSphere. We have Oracle. And we have Red Hat Enterprise Linux. So the world was very different. And we threw it over the wall, and it actually didn't run. It worked on my machine, but it didn't work on the machine it's supposed to. Have you guys ever had that situation, worked on my machine? I have it all the time to this day, right? I have developers who work with me on projects, and they're like, Burr, works on my laptop. I'm like, great, send me your laptop, because it doesn't work on my laptop. So the Docker file is what solved this problem for us, right? Or at least it addressed part of the problem. It addressed the issue of knowing what operating system was going to run inside that container. I could basically, on my Windows machine, add Linux, and basically run a Linux virtual machine, or in this case, a Linux container. And I could actually put the Java app server I needed with the right version of Java, or Node.js, or .NET Core, or whatever it might be. And I could run all that with my custom configuration, with my dependencies, configured correctly, bundle it up, and ship it to the next person down the pipeline. That was really the magic of it. Okay? Now here was the challenge with that Docker concept. If you had a bunch of these containers running on a bunch of computers, you had to manage them in some form or fashion. You had to orchestrate them. You could SSH into each machine. SSH into the first node, Docker run. SSH into the second node, Docker run. SSH into the third node, Docker run. Very easy to do. Many people do this in production all the time. Docker run, Docker run, Docker run, Docker run. But if you're trying to do this on your laptop, or if you're really trying to do it in production, it might be better to have software to do all that Docker running for you. Okay? So that's where Kubernetes comes in. Kubernetes, in this case, means governor or helmsman. It's a Greek nautical term, so there's all these sailing terms, nautical terms in the Kubernetes ecosystem. It is the container orchestrator. It is the thing responsible, the software responsible for Docker run, Docker run, Docker run, Docker run. And if something dies, it actually knows to solve that problem and Docker run it again. And if something is actually a zombie, think of a zombie shuffling around, walking dead, not doing anything of value, shoot it in the head and start it again. Okay, so that basically Kubernetes will do all that for you. And of course, it was inspired by Google, open sourced originally in 2014. That's when Red Hat got involved with this project in 2014, and we've been working with it ever since. Okay, so some key capabilities: self-healing, horizontal manual scaling or auto-scaling, automatic restarting, killing your zombies that are walking around, scheduled across numerous hosts. You might have 1,000 computers in your cluster. You'll see some of my clusters are rather small, some of them are rather big, but you can have many different nodes and build one big virtual computer for these guys. This is the ecosystem in which it's playing at this point. You're not supposed to be able to read this because there's just too many people playing in the Kubernetes ecosystem. It is a movement unto itself. As I said, if you know Linux, you need to know Kubernetes at this point. It is another skill that you ought to know in your toolbox as a software professional that will enable you to build better, faster software. Okay? Now, what is a pod? We refer to these things called pods in Kubernetes. This is a confusing term. Why don't we just call it a container? And that's because you can actually have more than one container in a Kubernetes pod. And actually, to make that point maybe a little more strongly, let's see here. You'll see this as we get going here. Well, here's a good example. Normally, you see one of one in a Kubernetes pod. One container, one pod. Okay, one and one. In this case, you can see two of two because there's a sidecar. And the sidecar gives us some very special features. In this case, auto-scaling and things of that nature. Or actually for this one, it's Istio. The sidecar allows me to do some really dynamic routing of the network logic. But look at this one, 11. 11 containers in a pod. So you can actually have more than one container in a pod, and that becomes incredibly powerful as you become more advanced with Kubernetes. So just keep that in mind. So that's the reason why the pod, okay? You know this, the pod, by the way, is a family of whales. The symbol of a Docker Linux container is the whale, and you have a family of those whales. You can have many of those whales. in this pod. So POD, become friendly with the pods. You can see it's here on my t-shirt, right? Be a friend of the pods. So the pod basically is more than one container, has a shared IP address, and has shared storage, and has shared resources, and a shared life cycle. All the containers, think of them as all those containers are simply processes in the operating system. It's my Tomcat, it might be my JVM, might be my Node.js, it might be this little sidecar, whatever it might be. They're just different processes, and they share the same IP address, which means they do have to have different ports. Everybody can't be running on 8080 in that case. Again, typically you have 1-to-1 until you get some very fancy things. So the pod is basically your computer, okay? That's where your application lives, and you'll see that when we get into it. The ReplicaSet or the deployment is responsible for managing that pod at scale. In other words, it's going to basically say, what do you want? And you're going to say, I want this image from Docker, I want this Docker Hub image, or this Quay.io image, or this image I built custom, my Linux container image, and I need to run 5 of those, 2 of those, 10 of those. And you would declare that in your deployment YAML. So you're going to see lots of YAML files here, and that'll run it at scale. Also the service. The service is separate from the actual pod, and this is actually a key piece of the magic. The service means that I have a stable IP address and a DNS name that is separate from the pods, which are more ephemeral. The pods can come and go. They might get rescheduled from one node to another node in the cluster because it dies, it becomes a zombie, has to get killed. The whole node died, something like that. But the service stays the same. So all the clients of that service are still talking to the same customer service, inventory service, HR, human resources service. That's the endpoint they're talking to, but the pods come and go. So that is actually a key piece of the magic. That's where the rolling upgrades happen. That's why I can do a 0 downtime blue-green deployment or canary deployment. Okay? There's also the concept of the PV or PVC, persistent volume. So Kubernetes had from the very early beginnings the concept of stateful applications as well. Not just stateless, not just 12-factor, but stateful applications, meaning applications that write to disk, applications that keep things in memory, applications that might have a shopping cart or users logged in, or things that are written to the actual inventory database. It might be MySQL or Postgres itself. Postgres running as a pod. It's going to be stateful, so the persistent volume is very important. And then there's the label. The labels you guys will get a chance to see because the labels are quite magical. The labels are critical because that is how Kubernetes figures out what does what. And it's just a key value pair, a tag. That's all it is. But based on those labels, they can figure out how to route traffic through a service to a specific pod or 2 or 3, or maybe it will group things in a certain way, and you will select on these labels. Okay? In the case of a Kubernetes cluster, you as a developer or operations team, by the way, how many ops side folks are here today? All right, only 3 or 4 of you, fantastic. And how many dev folks, developers? Okay, you notice when you raised your hands, the ops people are outnumbered, right? This is true in most enterprises. You got to keep that in mind and be nice to your ops people. Okay, they keep things running. But in this case, you can kind of see the developer and the operations team can collaborate around this API. The API is a RESTful API or a command line user interface or a graphical user interface to interact with this thing called Kubernetes. And the coolest thing about it is you simply declare your desire in the form of a document, like I want to run 3 of these Tomcats. And you shoot that document through the API, it lands in the etcd database, create, read, update, delete against the database, and then these schedulers and controllers kick on and decide how to make it real. So it has this concept of the reconciliation loop. It is doing everything asynchronously, eventually. I want 3 Tomcats. You basically post that, right, persist that into the etcd, and then the scheduler and controllers go, let me see if I can find 3 places to run these 3 Tomcats. And it does that by talking to this thing called the kubelet on the worker node. So this is my master node. The master nodes come in 3. Okay, etcd needs 3 to be highly available. So 3 is the magic number on masters. But you can have 1, I guess you could have 0, but 1 worker node up to 1,000 or more worker nodes. And you can put as many cores in there as you can handle when it comes to a Linux operating system. So I have some worker nodes with 32 cores in it. You can have some with maybe 64 cores in it. You can actually put a lot of CPUs in these things. But the kubelet is responsible for knowing how much available CPU this machine has, how much available memory this machine has, will the workload fit or not fit, or is something dead, or something a zombie, and addressing those points. So the kubelet is kind of interacting with that local node. And you can kind of see here I have a Spring Boot, might have Postgres, I might have Wildfly, MySQL, and that's basically what's running out here in these little pods, otherwise known as containers. So you basically say, I want a Tomcat with 4 replicas, and it finds a place to put 4 Tomcats. Okay, 4 Tomcats, drop in on those different nodes. And then if one of those Tomcats fails, because Tomcat can crash, you guys have seen that before, right? As a matter of fact, you might have been a bad programmer and forgot to do a try, catch, finally, and you might have eaten all the connections in a connection pool. I know no one here has ever done that sort of thing, okay? No one here has basically eaten all the threads in a thread pool by accident. But what happens in that case? The JVM, the process is still up, but it can't respond to any users. So Kubernetes is looking for that use case as well as the death use case. The process just died or the process is not responsive. If it's not responsive, that's the zombie I'm talking about. It'll either kill it or it knows it's dead and it'll start it someplace else. So in other words, the dead pod magically respawns someplace else. Now in this case, it's just starting a new process. It's another Docker run, okay, from that perspective. And if you have any state associated with it, hopefully you put that in a persistent volume. And the persistent volume is shared from one place to another. So you can have that in that situation. If the whole node fails, the whole machine goes away. And I've actually had this happen to me at Amazon. We were doing some real serious load testing on an OpenShift Kubernetes cluster, and we literally killed a piece of hardware in their data center. We know this because the node disappeared, and our system went haywire because we were doing some serious load testing at that moment, and we lost significant capacity when the machine died. We filed a ticket with Amazon, and they were like, yeah, we had hardware failure. So guess what? It's still a computer at the end of the day, and computers can fail. They will fail, as a matter of fact. Hopefully you've noticed this throughout your career that they might fail, but that's okay if it does fail. If it goes away, we'll just move those pods, and technically it's not moving the pod, it's respawning the pod someplace else. So that it always tries to keep that declarative state that you want. I want 4 Tomcats. Keep 4 Tomcats running for me if at all possible. If it doesn't have enough capacity, you'll notice the word pending on that pod, pending. And that's the signal to your brain to go, why is it pending so long? It might be it's pending because it's taking forever to get the image pulled in, or it might be it's pending because there's no place to run it. And there's another trick to that. It's called kubectl, kube control, get events. And you look at the event stream and it'll tell you, sorry, I couldn't find a place to put this pod. So it's going to be pending forever in some cases. Okay? A new node can be brought online because with a Kubernetes cluster, it can even bring up whole new nodes, and then it'll, of course, start moving new workloads there. Okay, so here's the concept of labels. You can see here I have app cool, env dev version 1, and that's my little wildfly right here. This is app cool dev version 2. And then over here I have cool prod version 1, so you see 1 and 1, 2 and 2. I have dev and dev, prod and prod, okay? All of those are part of the application cool though, cool application, it's just a tag. And then so I have all these wildflies here, but see these are my dev ones. So if I'm running a pipeline from dev to staging to production, okay, these are my dev ones. These are my prod ones. These are my version 1.0. Okay, you guys get that basic concept? The labels are just simply a way to group things, that's all. You are responsible for labeling things correctly. And I can tell you, I've messed this up a few times. I thought I had 1.0 labeled, but it was really the 2.0 image. You know, you can make that mistake because it's so easy to work with this highly dynamic configuration that you have here. If you think of it from a Docker run standpoint, where is that happening? You can see it right over here. Basically, you, the user, developer, or operations team, say, I would like to run this new Tomcat. I would like to run this new Spring Boot, this Node.js, this Python application, this Hadoop batch job, whatever it might be. That goes to etcd. The etcd, of course, now has that data in its database. The scheduler says, well, let me see if I can find a place to run it. Hey, kubelet, can you run it? Kubelet says, yes, Docker run. That's kind of the basic process here, okay? That you can see. Now, when we go to this tool called kubectl, kube control is actually its official name, kube control. That's the primary tool you interact with to try to make things work. Okay, so in other words, you have to interact with this cluster, and here I'll just show you that. Let's go to this cluster here. This is a mini kube, kubectl, get namespaces. So this is a brand new Minikube. You can see it has a default Kube node, Kube public, Kube system, Kubernetes dashboard. That is a brand new naked Minikube environment that I created. If I say kubectl get nodes, there's only one node. In this case, Minikube is a single virtual machine running on this laptop, and the master and worker are in one. This is not how you would go to production. Okay? You have to have 3 masters for a production workload with some number of workers to run the actual applications the users want to run. There is no magic here. If you need a CPU to run your application, you will need a CPU to run your application in Kubernetes. And I make that point because I've seen a lot of people who are new to Kubernetes are like, oh, there must be magic. I'm going to run these 25 applications, which all need a CPU, on a cluster with 4 CPUs. Now, technically, you can make that work if you play games, but it won't run well. I had one person tell me that their massive application that normally runs on a whole computer with 8 CPUs by itself, when they moved it to Kubernetes, they're like, it's horribly slow. I said, well, what resources did you give it? Well, they gave me the 1 CPU. I'm like, so you went from 8 to 1, and you don't understand why it's slow? And it was actually a very confusing point for the individual. They thought Kubernetes made magic happen. It does not defy the laws of physics. If you need a CPU, you need 2 gigs of RAM, you're still going to need a CPU and 2 gigs of RAM. You just got to know how to allocate it across the cluster. So in this case, you can see I have this one node here on Minikube. Let me go to my one of my crazier ones here. You can see I got all the kinds of stuff here, right? kubectl get nodes. This one has a master, a worker. See, that one's got a bunch of worker nodes there. I've got a whole bunch of worker nodes. So that one's running, of course, on Amazon. You can see it's running in Ireland there. And then if I look at this one, let's look at this one. Okay, kubectl get nodes. I don't need to leave that running anymore. But see, this one only has a couple worker nodes. So that's because these worker nodes have like 32 cores in them. They're really big machines. This over here has little 2-core machines. They're little tiny, like Raspberry Pis. So that's another thing you can do with Kubernetes, is you can specify the machine type at your various cloud provider. It might be a 32-core machine with 128 gigs of RAM, or it might be a 2-core with 8 gigs of RAM machine, like I believe these are right here. And you can scale these out by adding more nodes. Okay, that gives you additional capacity. So just keep that in mind. kubectl cluster info is one of your favorite tools. Okay, because that'll tell you a little bit more about which cluster I'm talking to. This is the one running on AWS. And if I come over here and look at this one, I got my Google one running over here. Yeah, come on, Google. Google's been struggling for me today. There we go. So that's my Google one, and that one's actually going back into the east coast of the US, as is Azure. I intended to move things into Germany and whatnot, and actually I often run my Google in India. So you just have to find a data center that works for you. Very popular options are, of course, Amazon, Google, and Azure, but also DigitalOcean, Minikube, lots of options to run a Kubernetes cluster. And in this case, I'm actually running OpenShift, these guys, and I'm using a technology called try.openshift.com, which allows me to run OpenShift at any cloud. Okay, so that's one thing also you can do. You use try.openshift.com, and then basically, once you log in here, let's see if I can remember my login. This is just a developer login you can get for free at Red Hat. Helps if I remember my password. No, Let's see if I got that right. And once you get in here, you can kind of see where you want to run it. I want to run on Amazon, Azure, Google, my laptop, maybe a set of bare metal machines or vSphere. So OpenShift, of course, is a nice Kubernetes distribution which you can run anywhere. Okay? Run it anywhere you want. So do be familiar with the kubectl tool. And also, if you are dealing with OpenShift, there's a second tool called OC. Okay? And OC is nothing more than a kube control, but has some additional features to it, additional capabilities. We at Red Hat actually work on both command line tools, both the kubectl as well as OC. All right, let's keep going here. Now, I don't want to harp on all this microservices stuff. We'll come back to that. You guys do need to check out the Quarkus session a little bit later today with Edson. Make sure you check that out if you want to see Java super fast and small. Basically, Java faster, smaller than Node.js. Okay, so that's one of my presentations that I'll show. But I want to get into this stuff here. Let's go here. Yeah, let's keep going. Try to move along here. Okay, Minikube allows you to run on a local host, local laptop environment. There's also a technology out there called Minishift, but you can do the GKE, AKS, EKS, and there's numerous options. There's 20 or 30 different places to run a Kubernetes cluster at this point. On your machines, on your Raspberry Pis, on a bunch of machines that you have at your local house or your local workstations. So do that in many different ways, okay? The things you need to be familiar with, though, as a developer in this space, is you got to be okay with the bash shell. If you're a Windows laptop using person and you're scared of the command line, and I know no Java person is, but if let's say you were a Visual Basic person, and I showed you this command line thing where you typed commands, I know that that is kind of scary for people. And we just had Halloween yesterday. Okay, I was over in Romania, in Transylvania, we were celebrating Halloween yesterday, and I showed people all this command line stuff. But you do have to be comfortable with a command line, bash shell, in this Linux Kubernetes world we're living in. If you notice, I pretty much only spent time on the command line so far, and we're going to spend a lot more time there. There's a tool for building your images called Docker. Many of you raised your hand earlier, you've used it before. There's an alternative tool called Podman, Podman. If you run on a Linux host, you can use Podman. And Podman has a couple of really special features. One, it does not require a Docker daemon, nor does it require you to be root to execute a build. While with Docker build, you have to have a daemon, and of course you have to be a root. You have to be a privileged user to run an image build. There's also a couple other tools, one called Builda, another called Kaneko, for building images in cluster. So Docker and Podman are for building images like on a laptop or workstation. Docker if you have a Mac or Windows, Podman if you have Linux. But the Kaneko or Builda is if you're building in cluster. So keep that in mind. You also have Git, right? GIT. You got to have a JDK, Apache Maven, maybe curl, tar for downloading. Homebrew for Mac is what I use a lot. The Kube control tool, and of course Minikube or something of that nature. Now there's a lot of options, as I mentioned these already. You can also build your own cluster using a tool called kubeadm. In other words, you can build a cluster from scratch, as long as you have access to the hardware and you understand basically how that hardware works. Okay, a lot of different options in this case. So I already have my Minikube running here, but I want to kind of show you some basic things. As I said, this is all documented out here. Okay, you can kind of see right here. This is the step one, installation getting started. I kind of walk you through, okay, how do you get access to the Kube control? How do you download it, okay? You can brew install it, or I often will download the specific version I want. In this case, apparently I'm using 1.14. Okay, and then I can set up that Minikube or Minishift environment. You do need to set some environment variables, and therefore you have to add the kubectl and Minikube to your path. That's very critical. And so if I come over here and say Minikube version, you can see it says 1.4 there. So that's important. And then you also want to set your config for a certain amount of memory and a certain amount of CPUs. So this is actually very important. By default, I think the default is still 2 gigs of RAM and 1 CPU. And the problem with that is you can't run a lot on that cloud, because what you're building is a little cloud here. You got to give it some memory and some CPUs to run the things you want to run. Again, there's no magic. If you have a Spring Boot application that needs a CPU and a gigabyte of RAM to run, you need to make sure that you have enough space here to run not only your application, but Kubernetes itself. Kubernetes and your apps have to live all in that space, all in that memory and CPU you give it there. I tend to use VirtualBox because that's available in all worlds, right? So Mac, Linux, Windows. But HyperKit is the one that's more performant on a Mac in particular. If you're dealing with KVM on a Linux machine, it doesn't really matter. You can pick and choose your hypervisor there. And of course, I use these profiles, and I like to be explicit about what Kubernetes version I'm using. And I think I need to update my documentation there. If I come over here, you can kind of see this is what I was using to, let's go check it out. So it's S. Cat start, dun, dun, dun. What I use? I think I used this script to start it. So here you can see I used 1.14. So Kubernetes 1.14. The reason I use 1.14, even though 1.16 is now out, is the majority of hosting providers supported versions of Kubernetes are about at 14 now. So you can always go to the latest, greatest Kubernetes, 16, 17. They're cranking out every 3 months or so. But the problem is, if you need support from somebody, a Google, an Amazon, a Red Hat, an IBM, they're going to be on a slightly older version. Okay, and so you need to go to the vendor of choice that you're working with and figure out exactly what version they support. Otherwise, you're going to be well ahead of the curve, you're going to find bugs, and there's no one there to help you if you fail. Okay, so you got to get that going. You can kind of see I have my Minikube running here. So here it is. I called this one 9 steps in this case. And you can kind of see, yep, oh yeah, we can do the config view. That's a good one. So in my case, I can happily copy and paste from here. There's the config view, and you can see, in fact, I did use 1.14 there. And then, if it's all good, this is a Minishift user interface. This is the Minikube user interface. We're going to ignore that for now. Get namespaces, kind of showed you that already. If it's an OpenShift, you do have to log in. OpenShift is a Kubernetes distribution that's secure by default. You want to make sure you log in there. And let's see what else we have here. Oh, this is a good one. Because it's a virtual machine, you can SSH into the Minikube. So I'm going to go inside the Minikube here, and then I can do ps-ef, right? I can do top. I can basically look around inside that virtual machine. In this case, it's a Linux. Look around inside that virtual machine that is Minikube, this guy right over here. Okay, so that's the guy I was poking around inside, and I can run top there. So keep that one in mind too. Okay, let's see what else we have here. Okay, deployments ReplicaSet. So the one thing you should always do when you touch a new Kubernetes. So here's a couple of key things to do. kubectl get pods -- all namespaces. What is already running on my Kubernetes that I'm talking to right now? And you can see even this Minikube has a bunch of things running. It has a bunch of pods running, and these things take up memory and CPU resources. So you want to make sure you're aware of that, because you might have already be using a lot of the memory that you might think you have access to. If I go back to my Minikube SSH, and I say free-h, all right, I can see that, okay, this one still has 4.7 gigs available. There's still some memory available. So you can kind of look at available versus free there. So available, you know, in this case, might be what you want. But if I come over here, you can see all those pods. And then let's come over here and grab this command, because let me go to another one of my clusters. Let's see, let's go to this one over here. All right. And I say get pods, all namespaces. Look at all these pods I already have running. So some clusters have a lot more running than others, depending on how they're configured. In this case, OpenShift itself is built on top of Kubernetes and OpenShift. And that's another thing you'll see. A whole portion of Kubernetes runs on Kubernetes as pods for the things and services that you need. So you have to kind of keep that in your mind too, that there's all these kind of things already running. Another command you want to make sure you need to know is get CRDs. Kube control get CRDs is a very critical command to know, because a custom resource definition is where someone has customized your Kubernetes. And going forward, almost all Kubernetes will be custom in some form or fashion. To give you an example of that, if I come over here, and, well, dun. Okay, what have you done? Okay, there we go. But let me go over here and let's grab this guy again. kubectl get CRDs. Get CRDs, you can kind of see there's a bunch of customizations to this cluster. Let's see, which ones do I have here? Do I have pipelines in this one? Like I have a pipeline object, so there's a pipeline object in that one. This one might have I don't know if I have a Kafka object. Nope, no Kafkas on that one, but I have Kafkas on this one. Okay. See, I have Kafkas. So, remember earlier when we talked about pod, deployment, service? Those are standard object types that are part of your schema. Standard object types that are part of your Kubernetes API. But now you can extend that API with customizations like Kafkas, like virtual services, like serverless services, like anything that you want within the ecosystem is often known as a CRD, custom resource definition, that extends the schema and API and gives you these new superpowers. This one right here actually is a Kafka cluster. All you have to do is declare your desire for a Kafka cluster, and one comes to life. As a matter of fact, let me just show you that. OC, new project. Let's just call this Burr. I'm going to just create a project called Burr, kubectl get namespaces. When I say project, that means namespace. It all means the same thing. Grab Burr. So there should be a Burr namespace here. There we go. and watch kubectl, get pods, and let me go show you what I mean by that declaration. GitHub, I got to find the right declaration for it, and I have all these examples out here. And let's see here, Kafka. I have some Kafka examples. I think it was this one. And kube files. And then let's see, hello Kafka OpenShift. Yeah. So let's edit that one. Right now it says DevOps. I was over at DevOps in St. Petersburg. And so this is Devoxx. Okay. Yeah, I think it's Devoxx. And then let's hit, we'll say Devoxx. Commit. I'm just editing the file directly on my GitHub repo. And then if we go raw, so that's my declaration. I want a Devoxx cluster of Kafka. See the kind Kafka here? I need 3 replicas, and I'm going to say 3 zookeepers and 3 Kafka brokers as an example. So again, this is kind of an advanced technique, but this is the way the world's going in Kubernetes. So if I say kubectl create -f, I'm just putting here in this middle window, right here, paste that in, unknown command, okay, the kube control create -f. There we go. I must have mispaced something there. But watch what happens. Basically, that kube control create sends the document to the API endpoint, which writes it to the etcd database, and then a controller kicks in to basically say, oh, you would like a Kafka now. Let me look at the document you've created and try to find a way to make that happen. So if I look over here, okay, let's look over here at this document, you'll see it basically says, I want a Kafka, I want 3 replicas of the Kafka broker, 3 replicas of the zookeeper. It has to bring the zookeepers online first, and you can see the zookeepers are coming up right now, and those pods are coming to life based on my declaration. So this simple concept is how everything works in Kubernetes land. You declare your desire with a document in a YAML form typically, and then it tries to figure out if it can make it happen. Does it have Kafkas, yes or no? In this case, this cluster has Kafkas. If I tried to do this on another cluster, which does not have Kafkas, like my minikube over here, let's see what message we get here, -f, and we try to run it. And so in this case, it says, sorry, I don't know what a Kafka is. You guys see that? So if you don't have the custom resource definition, you don't have the schema, you don't have the API, then it doesn't know what to do with the document in this case. But this other one did have a Kafka, and therefore it's making the Kafka come to life now. So there it goes. And then if I want to delete that guy, okay, so I did the create, I can say kubectl delete. Oh, let's do this way, kubectl get Kafkas. Oh, it helps if you spell Kafkas correctly. Kafkas, okay. There you can see there's the Devoxx cluster. I'll say kubectl delete Kafka. Devoxx cluster. We'll take it down. So create, read, update, delete. All those commands are part of the kube control command. So if you're used to reading and writing to a database, that's basically what we're doing here, okay? And you can see now I said delete the Devoxx cluster, and it's basically going out there, the controller, and tearing it down. Okay, that's part of the fun of you working in this Kubernetes world. So let's see here. Oh, let me go back and make sure we covered the key grounds here. Okay, there are a couple cool little things you can do with a run command here. Let me see if I have the right run command. Yes, right. Yeah, so there's a run command to basically pull an image and run it. Let's see if this will work for me. And let's go over here. And there we go. So I basically did kube control run, hello minikube. That creates for me, kubectl get deployments, a deployment, there's the deployment. It's going to create a pod for me, pods. There's the pod coming to life, container creating. Again, you can use kubectl, get events to watch that life cycle. Notice it's pulling the image from wherever it's pulling it from. In this case, it's coming from, this one's coming from GCRIO. So most often you see them coming from Docker.io, which is Docker Hub. But you might also see them coming from Quay.io. It's essentially just downloading that image across the internet to my cluster, to the worker node that's going to run it. In the case, this one right here is this worker node. but it might be one of my other clusters that has to pull it from wherever it is to that location. And you kind of see it's going to scale it up. So it's pulling, it's successfully pulled, and then runs it, all right? So if I say kubectl get pods, you can see there it is, up and running, 1 and 1 and ready. So there I have it, okay? I have that application now running, and if I look back over here, you can see there's my deployment. There's also a replica set. Whenever you have a deployment, it creates a replica set, which creates a pod, and a 3-step process like that. And then I can expose the service, okay? I can expose that service as a node port. kubectl get services. You can see there's my hello minikube there, and here is the port number, and I can say minikube dash profile, and this is 9 steps. What is the IP address? That is the IP address right there. So if I've done things correctly, I can say curl 192.168.99.100 and colon and 32.0.72. So 32.0.72. All right. So there it is. And that is actually that little application. What it does is simply just returns that basic, it's just an Nginx in that pod, in that image. Okay? So I can sit there and interact with it like that. So just think about that. You have this ability to deploy these images at scale. Okay? For instance, if I come over here now and say, watch kubectl get pods, there it is, up and running. And I say kubectl edit. Let's do this. Get deployment. Kubectl edit deployment. Hello minikube. Let me open that up. And I'm going to come in here and edit this deployment now. So this is a situation where the document is in the database over behind the API. But I said, give me the document back. Let me play with it a little bit. So I'm going to change the replica count to 3. Save and close, and because I changed my declaration, changed the document, Kubernetes is like, okay, you want 3 of those now, and it's spinning up 2 more, and there are 2 more running. And if I look back at my little service, where's my little curl command? Let's do this, okay. Okay, well, this will become more obvious in a second. There we go. So basically, when I'm doing this little curl command, I'm actually load balancing across all 3 of those. So it's not so obvious right now, but I'm hitting one of those 3 with every request. My users are being load balanced 33, 33, 34 percentage-wise across those 3 pods. Okay? And if I decide I no longer need this thing, get deployments. I no longer want it. You can see it has 3 pods ready for me, 3 up to date, 3 available, because I said 3. But let's say I no longer want this. I can say kubectl delete deployment. Hello minikube. Delete it, and it'll go away. They're terminating. So it's going out to my worker nodes and saying, shoot it in the head, shoot it in the head, shoot it in the head, kill it. I no longer need those things. That means the memory and CPU that it was using is now free and available to those worker nodes again. Again, this worker node is all right here. And then I also have that service. You also have to clean that up in this case. So delete the service, because the service will otherwise stick around. It just won't have, well, let's actually show you that. Where's my curl? Look at that. The service is still there, but there's nothing to talk to. All the pods are gone. So you should go ahead and clean up the service, delete service, hello minikube. All right, there we go. And we got rid of all that. So now everything is free and clear again. We're back to our previous state. kubectl get pods, -- all namespaces. All right, so you can kind of see we no longer have any of that hello minikube running anymore. But that is what's in step 1, to kind of walk you through these basics. You can kind of see I tried to document everything for you. So my goal is to do nothing more today than just show you these kind of cool things, and you go back and try it on your own local machine, okay? You use minikube on your Windows machine, your Mac. I did document everything here in Bash, so just keep that in mind. But we have a lot more to show you, okay? Because we have a whole nother hour left. We just scratched the surface. We're gonna have a little bit of fun with this. A couple key tips to remember. One is there's some directories out there that are created, a .cube directory or a .minikube directory. Sometimes they get a little bit messed up. I just will wipe them out entirely. I will delete these virtual machines and start again. I have recreated my clusters a lot. I will often do it before every presentation that I do. all right? In this case, I literally rebuilt this entire virtual machine knowing I was coming here today, right? I did it last night when I was leaving Romania. So it's really easy to do. You think of these things as highly ephemeral. You just basically recreate the cluster and then reload it with what you need. The downside to that is you have to wait for it to download the pieces that it needs. Okay, so whenever you're dealing with a Kubernetes world, you need to have good networking performance because it's constantly downloading all the pieces it can't find, which is a lot. Because almost the whole of Kubernetes is based on these Linux container images that have to get pulled from GCR.io, Quay.io, or Docker.io. And you'll see those bits streaming down, if you remember that pulling information we saw earlier. So lots of good tips there. Okay, now we're going to talk about step 2, because this is where it gets a little more interesting for a software developer. So in this case, we want to talk about the creation of your own custom image. Okay, so this is where you take your code and bundle it into an image that you then run on Kubernetes. So we talked a little bit about how to create namespaces. A namespace is nothing more than like a folder or a structure to put all your stuff in. It's a bucket. It's a place to put your deployments, your ReplicaSets, your pods, your PVCs, your config maps, all the objects, your Kafkas, your pizzas, whatever the object might be, you can load that into a certain namespace as an example, okay? In this case, just to walk you through basic, set up a namespace here, but let me go here now and let's go look at something. So here's my little Spring Boot application. Little simple Spring Boot application, fairly straightforward. You can kind of see it has this basic logic here, and again, this is part of the GitHub repo that I have for you. And I'm going to do something like, I'm going to get the host name. What computer does this little application think it's running on? I'm going to basically say aloha. If you call me and want to say hello, again, if you call the root here, it's going to return what aloha. It's going to return the host name, and it's also going to return this counter, this variable, but it basically shows you the life cycle of the JVM. Is the JVM still up? If so, the count goes up. But the JVM's been recycled, the count goes back to 0. So that's an important thing to kind of understand. It shows you the life cycle. So in this case, I can basically say Maven clean compile package. It is just a Java application. That's what you would normally do, right? Maven clean compile package. I do ls. I look at the target directory. You can see it's boot demo 001.jar right there. Okay, and then let's test it. As a good developer, I'm going to test it before I ship it. So I'm going to say boot demo 1. Yeah, there's the right one. All right, there's my Spring Boot coming online there. Let me come over here now and curl localhost 8080. There we go. It says aloha from Spring Boot 1 on unknown. I can curl it a few more times. Notice the number keeps going up there to 5. So now I have my Java application. I can easily deploy this into my Kubernetes world. Okay, but the first thing I got to do after I build the jar file or the war file or the application, I got to then build the image associated with that. Okay, so if I come here now, and we're going to create a namespace. So you can create the namespace MySpace right there. You can do it with a YAML file, or you can simply just do this. You can just simply say kubectl create namespace, MySpace. So I've created it, and I want to make it sticky, okay? So I don't want to have to type it all the time. So I have a special tool here called Kubernetes, which makes it the sticky one. It makes it so I don't have to type the namespace for every other command that I use, which is what you normally do in Kubernetes. You say -n, namespace name, for saying get pods, create, delete, etc., replace. So I'm going to do that, okay? And let's see here, okay? Notice right here, this is going to pull from Quay.io to create a pod. You can create a pod just by itself, but you actually should never do this really in real production. You want to create a pod from a deployment. So a deployment creates a replica set, creates a pod, but you can create them all individually separately. And in this case, you can see it's going to pull from Quay.io and not from the Docker image that I have. But let's look here for my Docker build. I'm going to come over here and say Docker build. And notice there's a Docker file right here. There's actually several Docker files, and when I just say dot, it's going to pick up the one called Docker file, not the others. And so, come on, I keep copying that. There we go. So we're going to do our Docker build, and let me see. Oh, I forgot to check something. Echo Docker host. Oh, I forgot to do something. Let me check something real quick. So in this case, I can use the Docker for Mac, okay? But I'm going to turn that off. Turn that off. So Docker images, Docker PS. See, I'm getting an error now. And what I want to do, if I'm a software developer, I want to use the Docker daemon that is in my Minikube or Minishift. Therefore, when I'm doing my builds, it's automatically available to Kubernetes. If you don't do this, you got to do your Docker build and then do a Docker push to a place that they can see it. So Docker build, Docker push, maybe to Quay.io, Docker.io, some other Docker registry, and then do the pull. In this case, I want to skip the push and the pull. So I'm going to basically say Minikube, profile, 9 steps, Docker env, and if I did that correctly, I can export these variables right here. And now when I say Docker images, I'm looking at the Docker registry that's part of Minikube. And you kind of see that there's the images that are associated with Minikube there. Kube proxy, the dashboard, etcd. Remember we talked about etcd already. So those things are already in there, including that little echo server I did earlier, okay? But now I'm going to say Docker PS. There you see there's a bunch of Docker containers already running because a pod is just a container, right? And then I want to do my Docker build again. So let me grab this one more time. And now I'm going to build against the Minikube's Docker daemon. And since this is the first time I've ever done this, it's doing the download of that image now. You can kind of see it going through the process of coming from OpenJDK 8.5. I'm picking 8U151 on purpose. But see, it's downloading that image. It's going to take a little while because the network here isn't very fast, let's say, but it's doing it now directly to this machine. And again, if I was working with a remote cluster, to kind of show you an example of that, I have lots of examples here. Let me open this up. If I was working with a remote cluster, like I am over here, I would do my Docker build, okay, and then I would do a Docker push. You would do a Docker tag and Docker push. So if you're going to, that way it's going to push out to that remote registry and then Kubernetes can download it from there. So you will see the registry like Quay.io here. Let's see, I have one Docker.io. So I use both registries. Those registries are visible here. Like here is my Quay.io as an example. Okay, and you kind of see I have images running out here now. We'll come play with that a little bit later. Let's go see if this thing is finished. Almost finished with this download. But does that make sense so far? The Docker pull, you got to do a build, you got to do the push, and then of course the pull. In this case, I'm kind of doing it all in one by talking directly to my Minikube as an example. And by the way, do you have any questions so far? Any random thoughts? We have a small enough group that you can throw a question at me. You don't have to just listen to me drone on, or you can throw something at me. I know you might be getting hungry as well, but we have like another hour to go of all this kind of crazy stuff we're going to show you. So let that finish. But maybe, yeah, let's actually try something real quick while that's cooking there. And actually, I was working on something else recently where I have was it this one? Maybe I came out with a better script for doing my build as an example. Maybe it was this one. I build all these scripts to kind of keep things sorted in my own head. Set up pipeline service. So this is a blue-green deployment presentation that I do. No, not that one. This one has pipelines built into it, things of that nature. Let's see here, not that one. I can't remember what I did with that other script. Let's close all that. I got too many things open. Okay, let's see. Did it get done there? Okay, so it's done. So it built this image. If I say Docker images, grep, this one was called 9 steps, right? There it is, 9 steps my boot. I can go ahead and do a Docker run, -IT-P, 8080 here, and say 9 steps, awesome, my boot, V1, do that. Let's run it. Okay, so I'm running that same Spring Boot application as I did before, but this time it's actually running as a container against the Minikube VM. If I say Minikube-profile, 9 steps, here, IP. What's the IP address? There's the IP address again. So curl, that one. In this case, it's 8080. And so there I'm interacting with it. And notice it now has a host name here at the bottom. And the reason I can interact with it, because I said 8080 here, right? So 8080 and 8080. Now I've shut it down, it's going to fail. There's nothing on that port anymore. Okay, so that means that my Docker image, my Docker container looks like it's kind of okay. So now I need to run it as a pod. So there are no pods here at this point in time. Well, you can see my get pods up here has no resources found. So no pods are running. How do we turn it into a pod? So if I come back to my documentation here, you can see there's the Docker run. I'm going to actually, though, use this deployment YAML, my boot deployment YAML. So let's see here. Dun, 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 dun. Let's open that up. I'm using Visual Studio Code, by the way. It's my favorite editor, and that's because Red Hat actually was a key contributor to Java language support for Visual Studio Code. Plus, we've also done YAML and made it Kubernetes and OpenShift friendly. So that's why I use this tool as my primary tool. It's a free tool available on all platforms, all open source. But if I come over here now and look at this deployment file, let's see here. Not the Spring Boot, not that one, this one. My boot deployment right here. So it has the kind deployment, see that? It has some labels associated with it. It also has a template and a spec, a pod specification. And I basically am going to use this image, the image you just saw me create earlier, okay, right there, and it's going to expose port 8080. So I'm going to basically just take that document and send it over to my Minikube cluster in this case. So I can say kubectl. Actually, let's do this. Let's do the watch again because it's a little more fun to watch it come to life. And then I say kubectl create -f kube files my boot deployment YAML, just like that. And when I run that, you will see that there's the pod coming to life. But what it did is it created a deployment, get deployments, because that's the kind it was, which creates a replica set. The replica set ensures that we have our desired number of replicas at all times. And of course, it creates the pod. Okay? And there we have it right there. And in order to talk to it, you create the deployment, then you create the service. So let me use this service right here. And so kubectl create -f kube files, and then my boot service. And then we're going to have a service, kubectl get service, right there. And see that node port available to me? So if you remember, we could do curl 192.168.99.100. That was the IP address of this Minikube. And then I can say 31.052. There we go. And so now I'm interacting with that guy right there. Okay. So what is it? While true, do curl 192.168. Let me see if I can get this right. 99.100. And then we're going to go with 31.052. Sleep for a little bit so we don't kill it, and then done. There we go. So see right there, it's just polling that little Spring Boot application. You can see the counter going up. So that's the one we just created, where it says aloha. But let me come over here now and say kubectl edit, let me look at my deployments, get deployments. You can see why I use all these little windows. All right, so kubectl edit, deployment, my boot, and let me make 3 replicas. I said 3. We're going to get 2 more pods come up. And notice there's some errors. There's some errors there, and that's because there's another thing I need to show you before we're finished with today's session. By default, Kubernetes says that as soon as that pod is created, it should be ready to receive load from the users. In this case, the JVM was not yet started. The Spring Framework was not yet started, because that takes time. JVMs, unless you're using Quarkus starts in 0.02 seconds. But if you're dealing with a JVM, you need 2 to 4 to 12 seconds. Or for some of your applications, it takes 30 seconds to start before it can serve. Therefore, you need a liveness probe and readiness probe, which we'll talk more about in a second. But you can see it does get sorted out. That's all good. And notice also it's load balancing across the 3. See, there's the machine name, the host name. See the host name right here? The pod identifier is also the host name of that machine. That is the computer at which that JVM thinks it's running on. Notice also they have different number values because they all are counting up based on their number. If I want to come in here now and change that deployment one more time, Let's say I want 5 of these. Change the replicas to 5. And then you're going to see 2 more get spawned. And there it goes. Again, some errors because of the fact that it hit them too quickly. Those things weren't quite alive yet. Those JVMs weren't quite up. But you can see based on the number 1 there, it basically started going. And if I want to, I can take it all down again. I can come back down to just 1 replica right there. And we'll see that it'll terminate the other 4 it doesn't need. So this concept of being able to scale up and down is a key part of a Kubernetes-based architecture. And all you do is declare based on that deployment artifact. So there it's taking them down, so those JVMs are going away. But do keep in mind, all of those JVMs are running inside this virtual machine, inside my worker node. If I didn't have enough memory, it would eventually stop. As a matter of fact, let's see if we can actually make it fail due to memory, just so you guys can see it. Let's go to, I don't know, 50. Let's see what happens. All right, I'm living dangerously here, but check this out. So it's still trying to work. It's still trying to go through the process, but see, it's trying to now create all those pods, the 50 I've asked for, and if I look here, dun, 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 see creating, see these pendings? kubectl get events. And let's see here. Okay, it's trying. kubectl get pods. Okay. kubectl get events. And there's actually a trick here. Let's see. Normally what you'll see in the event log is I don't have enough places to put all the requests that you've made, all these applications. Okay, let's see. Endpoint by boot. Okay, right. Sure, fine. Dun, 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 dun. Scale to 50. kubectl get pods. But the pending, it's actually trying to get them all started. Look at that. It's getting close. We may not, okay. It got them all started. Well, guess we're going to have to push it a little harder. Maybe we have to go a little harder here. It's acting a little bit funny. So that looks okay. Looks okay. Let's see. Let's try to really break it. Okay. So let's go to 100. As it tries to bring those guys up. And so you notice that it's taking a little while for the JVM to start. And notice actually right now I'm getting nothing but errors over here. Get events. Let's see. And now it's getting really slow. So what's another thing you can do too, because it is not, there's no free lunch here, right? You're still using the same set of CPUs, the same memory as before. So if I say minikube config, this is my profile, 9 steps, config view, right? I'm still using this 6 gigs of RAM and 2 CPUs. So I think at this point I did kill something, right? That's why you're getting this connection refused. It's certainly quite possible. And even the events won't show up here. Come on. Okay, maybe putting it to 100 was too much for it. Because Kubernetes itself is implemented as Kubernetes, you can kill it. And I might have done so here. Let's see, come on now. Oh boy. It won't let me go back in and fix that. Yeah, I think I've just now froze up my minikube. Oh, it responded once there. It's trying to respond. But hopefully that makes sense from that perspective, right? You can see that with your declarative desire, you can kind of do some crazy things, but you have to make sure that you live within the actual physics, the real estate that you have. But let's do this now. I'm going to come back over here, and let's see if we can do this one over here. Okay, this is a good one. kubectl get namespaces. One reason I keep a lot of clusters is I can destroy different ones and interact with them. Get pods. What do I have running here? Okay, this is actually running my Tecton pipelines. It's running my blue-green deployment. But this one actually has a fair bit of resources. Get nodes. This is actually a bunch of worker nodes here, so it's harder to run this one out of resources and see the issue that I'm talking about with the pending and the events. But in this case, it does seem like I clobbered it. So kubectl delete deployment. my boot. Let me see if I can just wipe out the entire deployment. Let's see if that'll respond. It might not. Okay, but let's let that sit there for a second. So you have all these different commands. You can do the get all to basically see all the objects in your namespace, the replica set, the pods, the deployment. You can create the service. We mentioned that earlier. And of course, you can curl it. I showed you that. Showed you this while loop here as well. We did a bunch of crazy scaling. In my case, I took it too far apparently and made it 100, but you can make it 3. Notice there's this cool patch command right here. And with the patch command, you can basically just use that to modify the replicas without having to actually edit the document directly, which is nice. Okay? You can, of course, change the code, do a new Docker build with a new tag, in this case, version 2, and then you can do the rolling update to that version 2 or to version 3, and you can roll it back. So that's a key feature of Kubernetes also. Rolling updates are built right into the architecture. That's the original feature that it had and showed people. You can see I want to set the image here to version 2, and you'll see it roll over to version 2, and then if you want to undo that, you can undo it, roll it out, okay? Undo the rollout, as an example. And that is all part of this key architecture here. What else do we have? If you're dealing with Java, you might have the out of memory killed, because by default, Java, if you're not taking good care of it, will try to use more memory and more CPU than it's allowed to use by default. So you have to watch for that OM killed. You will see this message from time to time. Let's see if we were able to delete nope, we weren't able to delete able to delete it. Okay, well, so I killed that Minikube, it looks like. 9 steps. Stop. Oh, let's just stop the VM. And like I said, I often will rebuild these VMs on a regular basis. So we're going to hopefully see this VM stop if it can get any response at all. So because I used all the resources on it though, even the network couldn't connect to it anymore. And then you just recreate the VM. So no harm, no foul there. One other thing I'll show you though that's kind of interesting, if you have access to an OpenShift, they do have the ability to come in here and say add, let's pick a different project. Let's pick this Burr project, okay? Add, pick a resource from Git. So I might want to say, let's go out to Git, and I want to run this Node.js project as an example. Okay, show advanced Git options. And then, no, I don't need all that. But I can run this sample repository here. I can just pick something from Git and deploy it the same way. Okay, so let's see if that'll let me do that. And create application, sure. Node, and then Node.js, and create, if I did that correctly. So in other words, there's lots of ways to get a pod started. There's the command line tool, which is true across all Kubernetes distributions, but then there's different user interfaces that every distribution will give you. In this case, this is one of the OpenShift user interfaces. If you have Google, if you have Amazon, if you have Azure, they'll give you a different user interface as an example. But this is doing the same thing that I did earlier. It's just with a point and click. If I want to pull an image from a container image, or pick something from the catalog, or load from a Docker file, or load a YAML, I could do that also. So there's a lot of different options when it comes to pulling in an image from a remote resource. And let's see here. I'm curious to see if this little Node.js app will come to life. So it's probably still pulling that image. And here, see that? I'm kind of curious if I go look at the administrative console and look at the events. There it is. It's going through that build process right now. So you can kind of see it is going through its build process where it's got to do the git clone, it's got to build the image, and then pull all the resources for it, and then run it. And man, the stop here is not working. So let's see if I can do a delete. There we go. We are able to delete it. So I just crashed it. No big deal there. Start Minikube. Let's bring up my Minikube back again. So in this case, I really have recreated my entire Minikube Kubernetes cluster, and you'll notice that it'll have to go through its startup process and download some things. Okay? But let me show you a couple other things here. Let's make sure we're covering the key ground at this point. Okay? So when you're building images and applications for Kubernetes, you have to find your base image, the from in your Docker file. Where are you going to get that base image from, where you basically say, I want a Java base image, a Linux, I want Ubuntu versus CentOS versus Fedora. What's that? Time's up? No, it goes to 2 o'clock. Right? Yeah. I can beat time up if you like. She acts like she needs me over there. So you basically will pull the base Docker image, and you got to pull them from a place you trust. So just one thing to keep in mind, your base Docker images that you pull from Docker IO often have a lot of critical vulnerabilities in them because there's no one grooming them or patching them. It's just community people like yourself who have to groom them and patch them. If you get them from Google, like GCRIO, or from Red Hat, they're responsible for ensuring there's no critical vulnerabilities inside those base images. The JVM-based image, the Node.js image, the Python image, the Postgres image, the MySQL image. So you will want to do that. You have to craft your Docker file accordingly to pull that image. And then, of course, you do your Docker build, as you saw me do earlier. And then you do your deployment and your service, and you're ready to go. Now, this last step here is kind of tricky, number 6, because it has to expose a URL that the user can interact with. That is unique per distribution. Okay, so in other words, Google is slightly different than Amazon, which is slightly different than Azure, which is slightly different than Red Hat's OpenShift. So just keep that in mind. Step 6 here will be unique, and you'd have to consult the documentation for your cluster you're using. And it's called Ingress by default, INGRESS, but everybody kind of does it a little bit differently to expose that load balancer. Okay, so make sure you know how to do all that, and then you're good to go. One couple things for building images, as I mentioned this earlier, typically use DOCKER build, like I would on my laptop, but there's other tools associated with this. Like this one's pretty interesting called Jib. It's a Maven plugin, and there's an example in my repo where you can build your image using just the Maven plugin, which is pretty awesome. And there's other tools like Decorate that are out now, and a bunch of cool other ones. This is one I've been working with a lot lately called Knative Build, but Knative Build has changed its name to Tekton. And you can do a whole pipeline in this case. So a pipeline of tasks and a series of steps per task. And so all that runs as Kubernetes native object types, and it'll orchestrate a whole pipeline. It'll basically do your git clone, do your Maven package, do your Maven test, do your Docker build. In this case, they'll use Kaneko or Builda. And then, of course, it'll roll it out into your production runtime. Okay, so that's all part of Tekton now. You will see people who are getting rid of DOCKER, so that's some options there, Podman and Kaneko as an example. And build packs and S2I work in a very similar way. So these two are actually fairly similar, S2I and build packs, and that is where you don't have to have a Docker image or Docker file. It'll just look at your source code repository and interpret what it is and try to deploy the image appropriate for it. And actually, let's go back and look at my one I was trying earlier. Let's see, that one looks like it may have been done. Let's go back and look at that one I was deploying earlier. There it is. Okay, and there is the URL for it. And there's the application. So you guys could even hit that URL yourself if you want to. So it deployed that application using the S2I technique. So in other words, there is no Docker file, there is no deployment YAML, there's no service YAML. It looks at the thing in the GitHub repo and tries to make a proper decision around it. And so we refer to that as S2I as an example. So there's a lot of different ways to do this within the Kubernetes ecosystem, and that was S2I in action, what I showed you there. Okay? And it looks like I've got my Minikube back up again. And, all right, namespaces. Okay, so there's no more Spring Boot in there anymore, but I was able to get my whole cluster back to life. So as I mentioned earlier, I'm constantly destroying clusters, recreating clusters. In this case, I killed it, not expecting to kill it, but that's okay too. If you can't tell, I came into Kyiv at 4 a.m. this morning, via Turkey, so I'm a little bit punchy after having not slept very much. So another good tool to check out is JShift. You notice I have some duplicate things in here. It's because I've been working on these slides and trying to figure out what the right update is. But JShift is another cool tool that I have demos of that is pretty awesome. So there's lots of cool tools for helping you build your images. There's a ton of tools for building images at this point. It's not just Docker build. Also for managing your YAML, a Helm chart is the most popular way to deal with all the different YAMLs, but another one called Customize is now built into the 1.14 Kubernetes directly. So customize, in other words, you have in the tool itself, kube control customized. And that simply allows you to do templated YAML, where you might replace things like version strings or environment variables or labels. Like, I'm going to deploy to production this way, but to staging that way. I want to do the rolling update from version 1 to version 2, things like that. Okay? Another thing to go beyond YAML and beyond basic controllers is this concept of the operator. And if you remember earlier when I showed you the Kafka in the presentation, right, when I did that Kafka's, so if I said, there's my Node.js, funny. So kubectl get Kafka's -- all namespaces. Right, so remember I had that my cluster that I created earlier? So when I do Kafka's, that's actually based on this concept of operators. So if I go here to operator hub IO, okay, this is where I can basically now augment and change my Kubernetes cluster. So if I look at Kafka, here's the Stremzy operator that I was specifically working with. I can say install, and then I can basically just copy these commands and come over here to my Minikube and run that one. And it's going to go through the process of installing the operator, the controller, the CRD, custom resource definition for Kafka's, into this cluster that otherwise did not have it. So if I say kubectl get CRDs, okay, there's not much, you notice these operators are now getting installed there. And this will take a little time to actually go through the process, but the operator hub is the way you can augment your cluster, okay? So what we've done is now we've gone very far into this Kubernetes world. You have your deployment, your ReplicaSet, your pod, all those basic concepts. But then I showed you Kafka's, and this is how you would get a Kafka loaded into your cluster. Just be aware of that, right? So you can kind of see it's going to create the Kafka operator in the step 2, and then of course all you do is simply say, I want Kafka objects from that point forward. And this is known as operator hub IO, right? Operator hub IO. And that is a new thing that's in the ecosystem at this point. And so that's really what this slide is all about. So a screenshot of that. And here's a Docker file for Java projects. We showed you that one already. No big deal there. Again, watch out for 8U, 121, 131, 151. They have the out of memory failed issue. So just be aware of that. If you have the latest 8, it's actually been patched in the latest 8. So just know exactly what minor version string you have for your 8, Java 8. Otherwise, it may exhibit the poor behavior or not poor behavior. All right, you want to make sure you keep that in mind. There's also the concept of logs. So if you have your running application, let's see here. Okay, QOC project, side by side. This is one of my other clusters. If I say kubectl, kubectl get pods. Okay, let me bring up the Node.js. Now I'll just bring up a bunch of different things here. Let's bring up the Quarkus application. I can bring up my Spring Boot. Let's not do that one yet. Okay, but see the Node.js application right there? I can use kubectl logs, and you pick the pod name. So you would have to give it the pod name, and you can see it'll pull the logs, okay? Oh, and in this case, it'll say, what container do you mean? I want the C user container. There we go. So see, it's just an NPM, okay? NPM start. If I look at this Quarkus one, kubectl logs, name of the pod, C user container, it'll give me the logs for that. But there's another tool that I really love, and it's called Stern. And with Stern, you don't have to give it the whole pod name. I can just say noded. I can give it a description of the pod, and it'll try to figure out what pod I mean. And also, it follows the log. Okay? In other words, you can kind of watch the log. So if we look at Quarked here, it'll follow the log. And then if there's more logging being done, you'll see those logs come out. So this tool is called Stern. So one of my favorite tools for pulling logs out of a Kubernetes cluster. In this case, this cluster is, I can't remember. Let's go look. Echo kube config. All right, this is my Azure cluster running back in the United States. So it's even pulling the logs from the United States over to here. Okay, so you can actually grab the logs from the different pods. So just be in mind that as a developer, you're going to pull those logs. There's also another tool called EXE or exec. That's a very powerful tool because I can basically say kubectl get pods. So here are those pods right there. I can come over here now to this one, kubectl exec -it interactive, paste in the pod identifier, bin bash, and I'm going to basically SSH from Ukraine into the United States into that pod now. So in other words, I'm living inside that pod, that Node.js pod, the one you see being curled down here, and I can just poke around a little bit. You want to be careful and never do this in production, by the way, because you're basically in the real production runtime environment, but you can, as a developer, you can now do some debugging. Like, why is it not running correctly? What version of Node did I have? What NPM version did I have here? I think it's -v. Maybe I'm wrong. I can't remember. -v? Or is it version? I can't remember how you get the version out of it. But, you would basically just have to go in there and interact with it, and then you could also see, okay, there we go. So we got 6.4.1. I got a pretty old version there, and that might be my problem. That might be why my application is not running correctly. So just keep that in mind. The exec command is incredibly powerful, and this example here walks you through a few different options of the exec command. You can also use the exec IT for interactive, but you can also do this one. I think I have it here. Oh, I don't have the example here. It must be in my other documentation. Dun, 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 dun. You can also say just run the exec command with a command, and it just returns the results. So let's see here. Dun, 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 dun. Where is it? So that's the IT version. Again, you can do bash shell or regular shell, SH. Top, look at the OS release, look at memory. You can then talk with localhost, because once you're in the machine, right, localhost. Let me see, I have another version of this though. It uses a -- in the syntax. Maybe I didn't write it down. Let's see, Kubernetes, kubectl cheat sheet. You'll see it here. So I mentioned this in my presentation, that you should know about this cheat sheet, exec, and you kind of see what I'm talking about when it comes to syntax. The -- means just execute that command and give me the results back here. So don't SSH in there. Yeah. What time is it now? 1:30? Okay. So I like the exec command a lot, though, because that allows me to do a lot of great debugging. It allows me to dig in and change things and understand exactly what's going on from the perspective of what's running in that pod. So that's a critical aspect of that. And basically, I want to get into that pod and see what everything is doing. So remember the exec command, the key element of setting this up. And then if you look here, there's also the concept of environment variables and config maps. So if you're thinking of a 12-factor application, you can have a property file where you override the environment variables for that application image. So you have your application image, but you might want to say, well, in production, I want to connect to this database. In staging, I want to connect to a different database. So that ability to override your environment variables is also a very important concept. You use this thing called a config map. Your config map can be created from a properties file. Then inside your deployment, you'll reference it, as you see here, environment from, here at the bottom of the screen. And then your code simply just loads those environment variables. So in other words, you can override the environment variables for the deployment from the config map. It's kind of the idea. If you have a password, you would use a secret, okay? Now, the secret is not encrypted. It just happens to be separate from the config map. That's all. So you just have those in a separate location. If you wish to have them encrypted, you'd have to go get a third-party product like HashiCorp's Vault, which gives you encryption over your secrets. But if you have a password for a database connection or a password for a JMS message queue connection, then you would put that in a secret, okay? So that's really what those config maps do. I want to show you, though, some really key aspects of this. Let's try to get our Spring Boot back to life, only because I want to show you something that's kind of important. Let's come back over here. Okay, so we have that finally finished, but we're going to ignore that for now. Get namespaces. kubectl create namespace. Let's just call this thing Burr boot just give it a name. There we go. I want to load up my Spring Boot application one more time. So let's do this. Yeah, we're going to run that one. Create-F. My cube files. This is my boot quay. Deployment quay. Nope, don't do that. There we go. Watch kubectl get pods. So that should be bringing, so in this case, it's going to be doing the download of that image from quay.io, kubectl get events. Okay, so there it is. You can see it's pulling the image right now from quay.io. This is my quay.io over here. And then here's my boot, wherever it is. There it is. Okay, let's look at my boot here and look at the tags. You can see I have a version 1 and a version 2, built 9 months ago. I've not even touched these things in a while. But you can see it's going through that container creating phase. That's because it's pulling, and it takes a while to do that pull. And it's pulling, of course, in this case, from quay.io, probably somewhere in the United States, over here to this laptop here on stage. So it might take a little while to do that pull. But then I can actually have some real fun with it, and that's actually what I want to show you. Because the real powerful aspect of this is when you start doing these declarative deployments, you can do things like setting the configuration in your deployment, also setting the resource allocations, like how much memory it's allowed to use, and this request is basically a signal to the scheduler. Find me a worker node that has at least 300 megs of RAM and a quarter core available, and the limit is the real hard cgroups limit that's built into the Linux kernel. So this is why Java may fail. Cgroups is a hard limit. If you try to exceed these boundaries, cgroups, the Linux kernel, will shoot you in the head. It will kill you. OOM killed, that's why you see it. So you cannot go beyond a single core, and you cannot go beyond the 400 megs you see here, okay? So those resource requests are very important, but let me see, did it pull this thing yet? Still pulling, still pulling. Maybe I should have used the local one instead. We can do that. Let's see, echo, minikube, profile, 9 steps, Docker env. Let's make sure these are configured again. Okay, Docker images, Docker PS, hello, Spring Boot. Okay, Docker build -t. We call this thing 9 steps. Awesome. My boot v1 dot. This might go faster. We'll find out. Oh no, now it's running. Look, that other one finished already. I was going to try to beat it. Get pods, get events. Yeah, see, it got through the pull. It actually run the image, okay? So kubectl, let's actually just keep with that one then, the one that just downloaded. So create -f dot kube files, my boot service. Okay, so kubectl get services. That is the 3106. So what is our IP address? Dash profile 9 steps IP. Am I going too fast? Like I said, I didn't sleep much, so this is kind of me in slow mode. Let's see here. Okay, 31086. There we go. So that's the guy we're dealing with there. Okay, and let me do kubectl edit deployment. My boot. Let's go in here. I want to get the replicas. Now let's not go to 100 and kill the whole system this time. Let's just go to 2. All right, there comes our second one. And then we say while true, do. Let's get this curl command over here. Okay, sleep for just a bit. Done. There we go. So it should be load balancing back and forth. Okay. So the thing I want to make sure you guys get, though, is this concept of the liveness probe and readiness probe. So let's see if we can solve this riddle. Okay, so this is the command here. Let's move this down here, this window. Okay, that way we have this space here to work with. Let's go do this. Let's see here. I'm just kind of hacking at this point, but let's call this bonjour. Hit save. Maven, clean, compile, package. And actually, I could just say package, right? And then we're going to build that fat jar. Again, java-jar, boot demo jar, there we go. Let's see here, curl localhost. Is that the one? Yep, there's the bonjour one, fantastic. Okay, put that back up there. And then we'll do our Docker build, -t, 9 steps, awesome. Okay, my boot, v2. There we go, we're gonna do our Docker build here. There we go, so this is gonna be the version 2 of it. Now here's what's interesting, currently I'm using the image from Quay.io up here. But we're going to try to have a little fun with this. Let's see. Okay. Let me make sure I have my command right. Dun, dun, dun. Is it this one? Set image. Yeah, let's try that. I'm going to try to override that image that's actually currently, if I say kubectl, edit deployment, my boot. Basically, the thing I'm overriding is this right here, okay? So that's basically pulling from the Quay.io image, but I want to override it and update it. Let's see how this plays out. So come on, build that image, get that going. Oh boy, it's going to take forever to download that one and get that going. Okay, well let's do this then. Yeah, not that. Watch. Okay, we're not going to wait on that one. Edit, deployment. Let's just pick the one from Quay.io. The version 2 shouldn't be a big download because again, all the downloads are based on the layers. So where's the image? Let's try this. 2, save, close, and notice it's doing its rolling update. Okay, so it's doing container creating, and when it goes to running, it'll basically turn, okay, and notice it's failing. I expected this. So basically, it's running, but the JVM is not yet up, okay? So we just did a rolling update. If I come back now, you can see it says bonjour. Let me roll this back to v1, save. Okay, now it's gonna roll backwards, right? It's gonna go back from bonjour to the aloha. Again, we see the failure. And there we go, okay. Okay, but let's fix that failure. This is the thing I really want to make sure you guys understand, and that is you have to have your liveness probe and readiness probe configured correctly. So what I want to do is I'm going to say, let's use this image here, right here, dun, 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 right here. And what we're doing is we're adding this liveness probe and readiness probe. So it's a 2-step process for Kubernetes. It's when it launches your container, it's going to say, are you alive and are you ready? It's a 2-question ask. Are you alive and are you ready? And you normally typically have these to different API endpoints. Like in this case, it's just going to the root. It's just doing a curl localhost, if you will. And this one's going to the health endpoint. But are you alive and ready? And this helps you avoid all those errors we were seeing. So let's try this one more time. So that currently says aloha. Let's come back over here now and just try to make it back to bonjour. So just so you see the error one more time, it's doing its rolling update, but it's giving us our users errors because it doesn't yet know it's live and ready. Okay, so let's do this then. kubectl replace -f kube files. This one was called live ready. I got the thing set correctly. So my boot, deployment, live and ready. I'm going to replace that object. Again, I'm going to get failures because the system isn't quite ready yet. And it's basically tearing down those old pods and bringing up the new pods to basically update that deployment artifact. Okay? And there we go. It's aloha now. All right, so let's try the same test we did earlier. There's my boot. Oh, okay. I'm going to go to my boot. I'm going to say I want 2 replicas. And I want this to be version 2. Save, close that, and then it should be rolling on to version 2. I did make the change. Okay, there we go. Now we see it. There's bonjour. And notice the smooth rolling update now. No errors. Because Kubernetes, but it did take longer. Kubernetes was able to say, is the JVM up? Is Spring Boot Framework up? Is the Node.js up? is it ready? So liveness says, are you responding at all? If you don't respond at all, the liveness probe tells Kubernetes to shoot you in the head. That's the zombie situation I talked about earlier. All your threads are gone from thread pool. The readiness probe says, are you ready for load balancing and user traffic? And if you know what you're doing with those two endpoints, you can do some really amazing things. With your readiness probe, you can basically hit your database, connect to it, build a connection pool, cache all the things you want to cache in memory, and then say you're ready. That means it's going to respond very rapidly to a user request. You can pre-warm your caches is a good example. So it's a very nice way of going. So if I come back over here and let's undo this rollout, go back to version 1, save, and then so it's going to undo it. But again, notice it's slower now. It's going through the process of saying starting. Notice this 0, 1, it's taking a while. And it's taking the time to basically look at this initial delay in seconds. So it actually takes up to 10 seconds to do the test before it even asks. Give the JVM 10 seconds to start. You want to make sure that you actually build these numbers appropriately for your application runtime and your infrastructure. If you set this number too low, initial delay second of 1, and your JVM can't start that fast, and these numbers are too low, it'll never be live. It'll never be ready. And that's a common mistake people make when they're working with these probes. So just watch out for that one. You want to make sure your numbers are high enough to let it get started. And then in this case, we went back to Aloha, right? Is that where we're going? Bonjour to Aloha? Okay. And then if I want to go back to Bonjour. So the liveness probe and readiness probe are incredibly powerful artifacts that you'll want to make sure you're very familiar with. Let's go to V2. And you notice it's not downloading the image again. It's not downloading the image again because of this tag right here. Image pool policy, if not present. If the image is not present, go ahead and download it across the internet. You can also say image pool policy never download the image, because if it's not there, I have a bigger problem. Where did the image go? It should have been cached in my infrastructure. We should be using an image that I know I put there. So often people say never in production. And then of course you can also say always. And for development, often I'll say always. Always pull the image. Because I'm assuming I'm updating it all the time. But I never would do that for production. Okay? All right, there we go. So, back and forth there. Okay, let's cover a couple more things. Let's see, load balancing, all that's for free. Service discovery is just based on the service name. If I say kubectl get services, okay, this right here is the DNS entry for that service, my boot in this case, and that's its name. That's how you refer to it. That's how you'll interact with it. No big deal. And it gets updated automatically by Kubernetes, which is nice. That's the live and readiness probe. You do the rolling updates, and then you can do like this blue-green deployment. And the blue-green deployment is actually very powerful, and it's built right into Kubernetes itself. The concept is you have two versions of the application in runtime, in production. I have blue or green, and the colors are arbitrary. You can basically call version 1 blue and version 2 green, or vice versa. It doesn't matter. But what happens is when you check your code into the source code repository, you do your git, commit, git push, right? A new build kicks off using some form of pipeline technology. Jenkins 2, which is built into like the OpenShift as an example, or Jenkins X, which uses things like Tecton. There's all these great pipeline technologies available in the Kubernetes ecosystem. So it'll do the git clone, it'll do the Maven package, it'll do the Docker build. And so you'll take that build and it'll go through your different phases. These are just namespaces in Kubernetes typically. I have a development namespace, a QA namespace, a staging namespace, and a production namespace. Maybe for production, I have it air-gapped. I have another Kubernetes cluster, and so it'll push it to a registry, and the other Kubernetes cluster will pull it to that other cluster, because I have very special needs to keep my production maybe separate from development, but you can also still put it all in one. Kubernetes has the concept of RBAC, right? So in other words, you can have very specific security controls over each namespace, like who can talk to which one. But when that build lands out there, that image build lands on green, you simply flip the router between the two. That's all you got to do. And then, if it fails, you flip it back. That is the beauty of the blue-green deployment. Okay? And so, we have a few moments. Maybe I can kind of show you this little piece of magic that I'm talking about here. And again, I try to document all these things. So this one I called number 10 here. It was fun stuff. So let's actually come over here and do these things real fast, okay? kubectl get all. There's nothing in this thing right now. Let's close this. And let's do this. I want to come over here to my Python. And actually, I can build them. This is what I was talking about earlier. You tag it and you push it, but I'm not going to do that. Yeah. So, where did I have these? I want to say I have these guys. Okay, let's do this real quick. Image pull policy ever, yeah. I'm kind of making this up now, but that's okay. I just need an editor real quick. So we're going to come here and basically say this is going to be my Quay.io. Oh, and this actually might be a good thing to show you. Here's my Quay.io. This is my Python. Let's go here. So my Python, and this has got a tag of 1.0.0. Okay, good. 1.0.0. Let's try to run it. Not never. Let's just say always. All right. And let's see if I can get this guy running. And I want to, if this works, okay, good. It failed like I expected to. See this actually right here? See the error image pull? So in this case, it can't pull that image, and this is just a fun way to show it because on Quay.io, it'll actually make a repository private. See the little lock there? And so I can make it public, and then you can pull it. So let's go here and make it public, switch that to public, and then see the image pull back off? kubectl get events. I'm getting errors. I can't pull it, I can't pull it, I can't pull it. But here's kind of, if things go correctly here, we'll just wait a second. Because the very nature of Kubernetes is if it can't solve a problem, it keeps trying to solve the problem. It does have an exponential back off, meaning it will, if it fails, back off, wait a second or two, try again. Oh, it fails, wait a little bit longer. And so you can get to this point where it's waiting a very long time between tries, but it should be that now I've made that image public, it should be able to pull it. Let's see, so it's backing off the pull on it. But once I've made it public, it should be able to go out there and get it. Okay, image pull back off, I know, but I made the image public, so go fetch it. Okay, well, let's leave that alone for now, and we'll come back to it. Let's go get this other guy here. Let's get these two guys as well. So this is the same application implemented in Go. It's just a hello world, Go, Python, etc. Let me go and write a little editor. Okay, I'm just using this for hacking purposes. Let's say always. Let's say this one always. And this is going to be Quay.io. Oh, you know what? I also didn't actually specify the name correctly over there. So no, that's why it's not going to even pull the image if you don't give it the right image name. kubectl get deployments. Is this a deployment or is this a pod? No, kubectl get pods. kubectl delete pod. It's not going to write itself if you don't give it the right name. Delete pod, my Python. Python. Okay, there we go. It helped. I didn't actually say Burr Sutter, and that's actually part of the image name. So let's get that there, and now it should come up. So come on, we'll come back to that in a second. And then I want to do the same thing here. Quay.io, Burr Sutter, got that one. That one looks good. And Quay.io, Burr Sutter, and that's probably fine too. Let's see if those work. And go here. Okay, so all those guys are trying to get downloaded now. Get events. And let's see, 54 seconds. Here's another trick that's actually a good tip to know. In our kubectl cheat sheet, get events, and notice this is one thing you'll really like here. Get events sorted. By default, the get events stream is not sorted, and you almost always want it sorted. I don't know why. I know why it's not the default. It's a performance thing. But so let's see. Okay, you always want to use this sorted option. And I'll just build myself a script. Otherwise, I won't remember that whole syntax. But see, it's pulling, successfully assigned, pulling the image. Okay, still pulling images. And assigned fun stuff. Boy, it's taking forever to get those images down here. Maybe be faster to build them locally. Okay, but we'll keep going. In this document, right, you can kind of see, okay, so set up a deployment, no big deal there. and create the service. So let's create the service. Create the service. kubectl, get service. Okay, kubectl, describe. So that's another key command to be aware of. Get describe service, my service. Okay, you can kind of see here where it says selector, in service my pods. You guys see that? kubectl, get pods, -- show labels. So remember the -- show labels command, and you can see the labels associated with those pods. And this service is looking for in service my pods. In other words, there are no pods behind it, and you can see the endpoints right here are none. See the endpoints none? So this service actually does nobody behind it right now. Of course, nobody's actually running right now. Get services. So if I say curl, let's do this, minikube -- profile, 9 steps IP. What's my IP address? Okay, good, it didn't change from before. Curl 32349. Okay, there's nothing there because there are no pods available. And why are these pods taking forever? Get events. Where's the long one there? Okay, again, I normally build a script out of this because that way I can remember it. Why is it not pulling those images? It's taking forever to pull those images. I guess it is downloading them across the internet here to on stage into this laptop and taking far too long to get those images to create and get those pods up. And see, it's been pulling now for a couple minutes, so it might not finish. But here's really the point. If you can get those labels set correctly, then your service will interact with them. So you can kind of see what you do here, right? You just have to label the pod accordingly. And right there. So basically, my node has been labeled with in service my pods. Yep, come on. It's still giving me an error on that Python one. Oh, it's giving me errors on all of them now. Look at that. But why is that label not updating? Cable label pod app my node. Oh, I see what I did here. See where it's not app my node. It is run my node. There we go. Now we see have this additional label. If I want to do one of these others. So this is not going to work if it's not going to be able to pull the images, but at least you can see what the action of it is. So see the in-service label I keep adding up here? So if I say kubectl describe, is it my service? Service? My service? kubectl get service, what do I call this thing? Oh, my service with a dash. All right. And if you look here, oh, endpoints. But you can see the endpoints is no longer none, but it's blank, probably because these pods aren't running yet. In other words, those pods, since they're not running, don't have IP addresses. But when they do have IP addresses, you'll see them in the endpoint section right here because they now adhere to the label. So if you can remember that piece of magic, then you kind of mastered most of the things that Kubernetes is doing that makes things kind of hard to understand. Okay, the labels that are on the pods basically means it shows up in the label selector for the service, and it'll show up as an endpoint if those things were actually running. Let's maybe another quick test on this. kubectl, create, get namespaces. Cube ns, Burr boot. Yes. Okay, kubectl create -f. I'm trying something on the fly here. My service. Is that what it was? kubectl get services. kubectl describe service, my service. And, okay, in service my pods, right? And then kubectl label, not my go, but app equal my boot. We should see the label show up there. There we go. Get services again. And it is this one right here, 30 Okay, so curl 192.168.99. You guys just like watching me struggle up here, don't you? That's what. You come to this session to basically say, what is this crazy guy going to type up there on stage? And did I not do that correctly right there? Dun, 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 dun. What is the 31086 is the previous one. Okay, that one's working. Why is my 30603? It's not working. I have to think about that a little bit, because we should have created that service correctly now. But describe service, my service. And see, it has the two endpoints right there. So that's the endpoints associated with those two pods. So I say kubectl, get pods. O wide. See? Right there, 10 and 14. So that's how you do all that mapping. But it doesn't seem to be working for me. Kubectl get services, kubectl delete service my boot. Let's get rid of the other one. And I don't think I need that. But why is that curl not working? I don't know. We'll have to I'll figure out what that is. Okay, but we are at a time. But just keep in mind, the IP addresses associated with the pods are ephemeral IP addresses. They're then tied to the service via the selector. And then once they're part of that load balancer, and as long as the label is set correctly, then you can do the load balancing across them. Okay? So this is really we call this one the 9 steps session. It can go through a lot of details. It is one of the 3 classes I teach, as I mentioned earlier, right? So this is the intro Kubernetes ones. There's an Istio one and a serverless one. I'll do a 1-hour version of the serverless session tomorrow here as well at Devoxx Ukraine. But all the content that you want is listed here, right? So if you look here, get these bit.ly links, make sure you have them. This is the things you saw me pulling out of GitHub today. Istio tutorial as well. We'll walk you through all the Istio capabilities. And then the Knative tutorial will be something available to you as well. And then, of course, this slide deck is bit.ly 9 steps awesome. And I thank you all for hanging out with me for 2 solid hours. I know that was painful. I do have a couple books. I have a few books. This is the Istio book that I worked on. There's a free version, by the way. If you go online, there's a free e-copy here that you can go get that. But I do have a couple physical ones to give away today. So I don't have a good raffle away process, so it might be just the first people to run up to the stage. How about that? So thank you guys so much. Yeah. Thank you.